Hey there, Dr. Corm here. How you doing? Algebra 2, Block 1B. Today is Wednesday, and I'm not here today, obviously. So here's the deal. I want to show you a couple things here on Canvas, as well as go over the quiz that you took last time. Let me start with Canvas first. So on Canvas, what I've got here, if you log into Canvas, is first of all the answer sheet to the quiz that you took on Monday, and I'll go over that in detail here in just a second. Also in Canvas, you've got the answers to the review sheets, the back sides of the sequence sheets that we've done in class the last few days, so to review for the final with that. And then also the last thing is a final review along with the answers that you will actually get a hard copy of from the sub today, but also the answers are available in PDF form as well as the questions. This is what's going to look exactly like the final test. Okay, so when it comes to the final test on Friday, what'll happen is the sub on Friday will instruct you to get into Canvas, and then you will click on quizzes. And when you click on quizzes, then this is what will pop up. This is not available yet. I will turn this on Friday so that semester 1 final algebra 2, you'll click on that and it'll get to those pages. So for right now, you cannot see that, but you will on Friday. But you do have access to the final review here. Okay. Now, again, these are all things that you can use today in class and at home the next 2 days to get ready for the final Friday. This right here is the quiz that we just took, and I want to go over that with you right now because I ended up starting to grade these things, and I saw some commonalities and some things that I didn't like, and so I ended up not grading them per se, but I gave you credit like an assignment. And so what I want to do is go over each part of this with you so that there's no confusion on the steps and so forth. So I want to make sure that we're all on the same page. I gave you assignment credit in the grade book, and I think that would end up helping your grade. If I just graded it straight out, it probably would hurt your grade. So I wanted to make sure that this assignment ended up, or this quiz ended up helping you and not hurting you. So just to go over it though, since you all have it, and those of you who didn't take it, you should get a blank copy of this so you can kind of fill this in. Those of you who did take it, you should have the copy that you turned in back to you, ungraded, unmarked, so that you can kind of go through this with me and understand what went well and what didn't. So, number one, the sequence here is arithmetic, because you have a common difference of -4, so therefore there's the recursive formula according to what we have in our notes. So just to get the next term, you have to take the previous term and subtract 4. How that relates to the explicit formula is this is the formula for explicit formula. In order to use explicit formula, you got to know what a sub 1 is as well as the common difference. Well, you do know what a sub 1 is, and you do know what the common difference is. So you can plug those in and put 95 and 4 or -4 in there, and this would have sufficed for an answer. Or if you wanted to make it nicer, you could have distributed the -4 and ended up with that, and then combine like terms to end up with -4 and plus 99. Either of those answers I would have accepted, okay? But in order to find the 27th term, you got to sub 27 in for n, and if you use this explicit formula, that is the answer using that explicit formula. If you use that explicit formula, that is the answer, but either way you should get -9 as the 27th term. Number 2, now you have a geometric formula, or a geometric sequence, because you multiply the previous term by -3 to get the next term. So therefore the recursive formula is to get the next term, you have to multiply the previous term by -3. Now, where it gets crazy though is that there is no such thing as an explicit formula for geometric sequences that we have covered in class. So if you put something there, I would have just given you credit for it, but we have not talked about that in class. Okay? Therefore, it makes it a little bit problematic to find the 14th term since there's no explicit formula. So the only way you could do it would be to use recursive formula. In order to find the 14th term, you got to know what the 13th term is. In order to find the 13th, then the 12th, etc. Okay? So that's the only way you could have done it, was just by multiplying each of the previous terms by -3, and you should have ended up with, for the 14th term, 1,594,323. So that's number 1 and 2. 3 and 4. Given the recursive formula, create the sequence, and I asked you to find the first 5 numbers of the sequence. So in order to get a sub 1, that starts with 3. To get a sub 2, okay, you just take -5 times the previous term. So -5 times 3 is -15. Then you take -5 times -15 to get 75, positive 75, and then etc. and so forth. Okay, so that's how you get the sequence. But again, write the explicit formula. Well, since you're multiplying, that is a geometric, and we don't have an explicit formula for that the way we studied it. Okay, so you just leave it like that. So number 4, now you've been given an explicit formula, and to create the sequence, to get a sub 1, you sub in 1 in for n right there. So 1 subtract 1 is 0. 2, -2 to the 0 power. Anything to the 0 power is a positive 1. 1 times positive 5 is positive 5. Okay? Therefore, to get the next number in the sequence, a sub 2, plug in 2. 2 minus 1 is 1. -2 to the first is -2. Times 5 is a -10. And you keep plugging in a sub 3, a sub 4, a sub 5 to get those 3 numbers there. Okay? Therefore, since you know you're multiplying times -2 to get from one to the next, that is your common ratio to plug in right there for your recursive formula. Okay? So that's number 3 and number 4. Now, moving on, 5 and 6. To do anything with the sigma notation, you've got to know that this right here is your formula to get the series. Okay? And so, in order to use this formula, you've got to know what the first term is and what the last term is. In order to do that, you plug in x equals 1 is the first term, 15th is the last term, so there's 15 numbers in the sequence. And all you have to do is plug 1 in here. 5 plus 3 times 1, 3 times 1 is 3, plus 5 is 8. That's where a sub 1 comes from. And then 15, you plug 15 in there. 3 times 15 is 45, plus 5 is 50. Once you know your a sub 1 and a sub 15, then you can substitute in appropriately. N is 15. A sub 1 is 8. A sub 15 is 50, divided by 2. And remember, parentheses first, order of operations, times 15. 58 times 15 is 870. Divide that by 2, you get 435. Okay? Same thing for number 6. You need to find your a sub 1 and your a sub 6. So again, this is a 6-term sequence here because of that. You plug in 1 here. 1 minus 1 is 0. 2 to the 0 power is 1. And so 1 times 5 is 5. To get a sub 6, 6 minus 1 is 5. 2 to the 5th power is 32. And then you multiply that times 5 to get 160. So now you've got everything you need to know to plug into the series formula to get the sum. So you plug in 6 right there because n is 6. You plug in 5 for a sub 1. Plug in 160 for a sub n. 160 plus 5 is 165 times 6 is 990. Divide by 2 to get 495. So that's number 6. And finally, number 7. You must show the sum of the first 35 terms in the series. Oh, well, easy enough. I'll just use my sum formula. But here's the problem. Okay, to get sum of 35, you could put 35 here, 35 here. You know your a sub 1 because they show that here. It is 4. Okay, divide by 2. But the only problem is you don't know what a sub n is. You don't know what the 35th term of the sequence is. So that's where explicit formula comes in, as we used earlier. To get the 35th term in the sequence, you need to know the common difference. You need to know a sub 1 to get a sub 35. So a sub 1 is 4. The common difference is 6. It goes up by 6 every time. And so those numbers go there. You plug in 35 for n, subtract 1, and again, order of operations. So many people look at this and go, oh, 4 plus 6, but that's not right. 35 minus 1 parentheses goes first. 34 times 6 is 204, plus 4 is 208. That is your 35th number of the sequence. Therefore, now you have all the information you need to plug into the main series formula. So n is 35. A sub 1 is 4, a sub n is 208, and then you just do the math from there. 4 plus 208 is 212 times 35 is 7,420, divide by 2, and the sum of the first 35 terms is 3,710. Okay, so that is the quiz, and so hopefully you have a better understanding of that. And again, this is all available. What I just went over is here as a PDF. The answers to the topic 1, 2, and 3 review sheets is there to study for the final. And then there's an actual kind of semi-final. What I would do this block is I would open this up or use a handout that the sub gave you and use that as a practice test. It has the answers on there, so you can look at your answers as you do it or afterwards. But pretend that's the final, use that as the final, and then go from there. On the final, you'll be allowed to use calculators from me. You'll be able to use scratch paper, and you'll be allowed to use your notes. So make sure all that stuff is available on Friday, and the sub will administer the final on Canvas. So please email me, ken.korm@nkcschools.org, if you need anything between now and Friday. Other than that, have a good time. Peace out.